Hello friends, I'm Kushal from Indeed Inspiring, and we have been discussing conditional probability. In the last video, we had discussed conditional probability formula, and you can see here that probability of A given B has already occurred is equal to probability of A intersection B divided by probability of B. Let us understand this concept with the help of some examples. The first example we have is about ice cream. I hope you also like ice cream. So in this example, we are having friends and 70% of our friends, they like chocolate, I mean chocolate ice creams, and 35% of our friends, they like both chocolate as well as strawberry. Now, the problem statement we have is we have to identify the probability that what is the percent of those who like chocolate also like strawberry. Okay, I'm repeating. What is the percentage of those who like chocolate but they also like strawberry? Okay, so putting this into the probability, conditional probability formula we have derived, so it can be put upon like this. So probability of strawberry given chocolate is already true, right? So chocolate, they like chocolate, is equal to probability of chocolate and strawberry divided by probability of chocolate. So look at the data given with us. So we have the data 70% of your friends like chocolate. Okay. So probability of chocolate, that is 0.7 or 70%, and 35% is chocolate and strawberry. Okay, so probability of people liking chocolate and strawberry, it is 35%. So 0.35 divided by 0.7 gives us 50%. So 50% is the answer, that the percent of those who like chocolate also like strawberry is 50%. Okay, let us move ahead and understand with one more example. In this example, we have considered people who owe a pet. Okay, they are owners of a pet. Here you can see the table, and the table describes males who have pets and who do not have pets. Okay, so 0.41, that is 41% male, they own pet, and those who do not have pets, they are 0.08. Okay, so the total, if you see, total number of males we have is 49%. Similar way, female who own a pet, 45%, and 0.06, that is 6%, they do not have a pet, but total number of females we have 51%. Okay, so total number of people who are having pet, irrespective of male and female, is 86% of people are having pet, and only 14% of people they don't have pet. Okay, so if you do the sum of 86 and 14, okay, or you do a sum of 49 and 51, it comes to be 1. Okay, so it will always become 1. Okay, so now what is the problem statement here? The problem statement here is, what is the probability a randomly selected person is male given that they own a pet? Okay, so what is prerequisite? What has already happened? They must own a pet. Okay, so all those people who own a pet, so here you can see all those people who own a pet, what is the probability that the randomly selected person would be a male? This is what we have to identify. Okay, so let us move ahead and understand in further slides. In the next slide, we are going to discuss about this table first before identifying the probability. So this table you might have seen in some more examples. And here you can see this table is called as contingency table. Why do we call it as contingency table or cross tables, or you can call it as two-way table? So why such a name given to this table? Because this table is helping us to summarize the relationship between categorical variables. In this case, we have categorical variables, that is male and female is a categorical variable we have, and pets and do not have pets. This is another categorical variable we have, and this table is giving a summary and relationship between these two variables. Okay, so this is called as a categorical variable. Now let us move ahead and continue with the example. So let us rewrite the formula here, and the formula is probability. Here you can see the formula. So probability m. So what is m here? Probability of m, that probability that the person will be a male given that the person is a pet owner. Okay, so probability that a man will be there, okay, given that he is a pet owner also, is equal to probability of man, okay, intersection pet owners divide by probability of pet owners. So this is the formula which is derived. Okay, now the next step, I have displayed the table in all the slides so that we are all able to understand each and every step. Second step is, now understand, find out probability of m intersection po. So find out probability of males, and males are pet owners. So you can see that 41% are males who are also pet owners. So 0.41 is the probability. All right. Now next, we have to find probability of pet owners. This is the total probability. So here you can see the total probability of pet owners, irrespective of whether they are male or female, is 86% or 0.86%. Now in the step 4, we will get the output. So substitute these values. So the values we have taken is 0.41 divided by 0.86, which comes to be 0.477, or 47.7 is the probability that it will be a man, given already the condition is given that they all are pet owners. Okay, so this is another example of conditional probability. Now we will move ahead and we will go for the Bayes theorem, but this will happen in the next tutorial, so keep watching. Thank you, thanks a lot.